This video is on phase diagrams. So a phase diagram is a diagram of the three states of matter, three phases that a substance can be in, the solid, liquid, and gas phase. A phase diagram, we can see here, has the axes of pressure in atmosphere and temperature in degrees Celsius, and it has this Y-looking shape to it. There are two specific points or important points on a phase diagram. One is the triple point, and this is the pressure and temperature at which all three states of matter exist simultaneously. And the critical point is when a pressure and temperature at which the distinction between liquid and gas can no longer be made. So it means there we can't tell if we have a gas or a liquid at that specific pressure and temperature. So if we take a look at our graph here, we have, like I said, pressures here, temperatures, and then we have these three distinct areas. We have an area here, here, and here. This area here is at low temperatures in any pressure. And one thing that we know about states of matter is that very, very low temperatures, things freeze. So this area of our graph is the solid area. This is where the solids are. My area here, this bottom part, is under low pressures and higher temperatures. So a low pressure means that things can expand, and at warm temperatures, higher temperatures, my state of matter is going to be a gas. In this middle area here, we're at varying pressures, varying temperatures. This is my liquid phase. Okay, so any pressure and temperature given here, this is going to be, my substance will be in the liquid phase. That item of a triple point that we talked about earlier, that is here on my curve. And my critical point is here. So these lines represent an equilibrium between the two phases that are on either side of him. So this line is an equilibrium between solid and liquid. Here, the line is an equilibrium between liquid and gas, and this line is the equilibrium between solid and gas. So that means that if I'm on this line, let's say I'm here, if I'm on this line, that means my substance is part solid, part liquid. If I go across this line to the right, from solid to liquid, I will have melted. And if I go the opposite way, if I'm at a constant pressure but I decrease my temperature across this line here, I will have froze. I will freeze. Going from solid to gas across this line, solid to gas is sublimation. And gas to solid, going the other direction, this is deposition. Here, all three of my phases are coexisting, so that's my triple point. And then if I cross this line, going from a liquid to a gas, I evaporate. And going from a gas to a liquid, I condense. Okay. Another important area of this graph is the temperature, or the temperatures that we get at 1 atmosphere. So 1 atmosphere, if we go across, hits my line here and here. For every substance, the phase diagram is different. This phase diagram just so happens to be of water, and I know that it's water because of this negatively sloping line between my solid and my liquid. The reason that this line has a negative slope is because a solid is less dense than liquid water. I'm going to refer back to this 1 atmosphere here. This 1 atmosphere is a normal atmospheric pressure. So 1 atmosphere is normal atmospheric pressure. And the temperatures that our lines cross at 1 atmosphere are called normal points. We can have a normal melting point. So we said melting was going from solid to liquid. So at 1, going from solid to liquid at this point here, coming down, I would get my normal melting point, which would for water is 0 degrees Celsius. And I melt and freeze at the same temperature. So going to the right from solid to liquid, I freeze. Going to the left from liquid to solid, solid to liquid, I melt. From liquid to solid, I freeze. So this happens at the exact same time because we get this equilibrium of the states. Then going further across till I get to my equilibrium line between liquid and gas, which is here, I come down and I see that my normal boiling point for water is 100 degrees Celsius. And again, boiling point, condensing point, same thing. Either I'm going across and I'm boiling or evaporating, or I'm going the opposite direction from gas to liquid and I'm condensing. But this all happens at this equilibrium between liquid and gas. So both points coexist. When we're looking at the phase changes, we need to think about these 2 words, endothermic and exothermic. So endothermic is absorbing heat where the temperature increases. This is things like melting, boiling, and sublimation. So melting, solid to liquid, boiling, liquid to gas, sublimation, solid to gas. And then things like exothermic, being a releasing of heat, right? Exo for exit, releasing heat, the temperature decreases. And so that's things like freezing, going from liquid to solid, condensing, gas to liquid, and then deposition, which is gas to solid. So this is like snow comes from water vapor and then turns into solid snow. Okay, so snow is deposition, or the act of deposition is snowing. So you can think that snow gets deposited on the ground, okay, kind of how you can remember deposition. If I were to draw my molecules, my liquid molecules would be moving faster than my solid molecules. My gas molecules moving faster than my liquid, and gas moving faster than my solid. So during these phase changes, my molecules are moving faster the more heat I apply, because remember, heat is energy. And then for my exothermic, these molecules are all slowing down. So liquid to solid, they're slowing down, gas to liquid slowing down, gas to solid slowing down again.